In this problem, we want to state the interval or intervals on which the function is continuous. This function is a piecewise function, so we're going to need to analyze each of the pieces first. So let's start with the first piece, which would be y equals cosine of t. We know that cosine is a continuous function over its entire domain, and the domain of cosine is all real numbers. So alone, we know that y equals the cosine of t is definitely going to be a continuous function. The second piece is going to be y equals 3. We know y equals 3 is a horizontal line, and that certainly is a continuous function over all real numbers. The third piece is y is equal to the sine of t. And just like cosine of t, we also know that sine of t is a continuous function over its domain, which is all real numbers. So all three of the individual pieces are continuous functions over all real numbers. Therefore, we really just need to take a look at where these functions meet. And it appears that they're going to be meeting around 0, so we need to check for continuity at 0. Now, in order to check for continuity at a specific point, there are basically 3 conditions that must be met in order for a function to be continuous at a point. So let's first review those. So the first condition that needs to be met in order for this piecewise function to be continuous at t equals 0 is that f of 0 needs to be defined. So this first condition here says f of a is defined. We're looking for continuity at 0, so we're going to check to see if f of 0 is defined. Now our function is named g, so that means we're checking to see if g of 0 is defined. And you can see right here in our piecewise function that when t is equal to 0, the output is 3. So yes, g of 0 is defined, and in fact we know that the value at 0 is 3. So the first condition has been met. The second condition says that in order for the function to be continuous at a specific point, the limit must be defined. In other words, the limit must exist. So for our second condition, we need to determine if the limit exists as t approaches 0. I almost wrote x approaches 0 here. Let me get rid of that and make that accurate. The limit as t approaches 0. So we're looking for the limit as t approaches 0 of our function g of t. Now, because g is a piecewise function, we're going to determine the value of this limit by looking at the one-sided limits. So the limit as t approaches 0 from the left, as well as the limit as t approaches 0 from the right. Now, if we're interested in the limit as t approaches 0 from the left, then we're interested in values smaller than 0. So if t is less than 0, then that means we are on the sine of t portion of our function. So we'll be looking at the limit of sine of t as t approaches 0. We can go ahead and do direct substitution here and plug in 0 for t. That gives us the sine of 0, and the sine of 0 is 0. Now, if we're interested in approaching 0 from the right, looking at values larger than 0, that means t is greater than 0, and that means we are on the cosine of t function. So this will be the limit of cosine of t as t approaches 0 from the right. Doing direct substitution gives us cosine of 0, and the cosine of 0 is 1. Now, because the left-hand and right-hand limits are different, that tells us that the limit as t approaches 0 doesn't exist. And that means that the second condition for continuity at a point is failing. This function is not continuous at t equals 0 because the limit as t approaches 0 of the function does not exist. Now, if you reread the actual question here, it said state the intervals on which the function is continuous. So we've determined that the function is not continuous at t equals 0. Therefore, it is continuous everywhere else. And since the domain of both cosine and sine, the domain is all real numbers, we can say that this function is continuous at all real numbers except for 0. So my summary statement could be written something like this. G of t is continuous, and the way we can write all real numbers except for 0 is we can write negative infinity to 0, union 0 to infinity, with parentheses indicating that we are not including 0. So g of t is continuous on the interval, or intervals, where t is an element of the interval negative infinity to 0, union 0 to infinity. This will be where g is continuous.